Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fauzan bin Harun. My matric number is 1623021. Today I will present my FYP1 entitled Investigation of Ceramic Tile Waste as Aggregates Modifier in Hot Mix Asphalt HMA. This is my presentation outline. It is divided into 4 parts, which is the introduction, literature review, methodology, conclusion, and future works. For the introduction part, we need to know that Malaysian economy shows a significant rise over the last 2 decades up until today, especially in the manufacturing sectors. One of them is ceramic tile manufacturing, which is highly demanding in the construction industry. Ceramic tile is widely used construction materials. For example, ceramic floor tiles, wall tiles, and various clay building bricks. We also need to know about hot mix asphalt, which is the mixture of aggregates and bitumen. HMA is widely used in road construction. The demand for aggregates increased because it is used in building roads and concrete. The problem is when disposing of waste ceramic tile to landfills requires a lot of money to manufacturing companies. This is because the waste tiles need to undergo crushing procedure, which is normally expensive and really challenging for companies. Next, the dumping of ceramic tile waste will result in environmental degradation and bad visual scenery. Normally, tiles will not be decomposed at all, or it takes more than 10,000 years in order for the tiles to decompose at the landfill. Therefore, it will result in bad visual scenery. Next, aggregates production costs are quite expensive. So, replacing the aggregates with ceramic tile waste is an alternative method that can be used to overcome both problems. So here comes the objective of my study. The objective is to investigate the capability of using ceramic tile waste as aggregates in hot mix asphalt. I want to make sure whether ceramics is capable to replace aggregates in HMA or not. Second is to determine the optimum proportion of ceramic tile waste to replace the conventional granite aggregate. If the result shows a good capability of ceramic in replacing the granite aggregates, what is the best optimum proportion? For the literature review, Dr. Muniandi and her team replaced the conventional granite aggregate with ceramic aggregate proportion of 0% up to 100% weight of aggregates with increment of 20%. They conduct material testing, Marshall stability and flow test, and also resilient modulus test. From the test conducted, they conclude that 20% of ceramic waste in HMA improves up to 80% stability value and has lower optimum binder content compared to the control samples. From the result, it shows that 100% ceramic waste in hot mix asphalt decrease very much of the stability compared to control samples. Therefore, it is not recommended to use 100% ceramic waste in the hot mix asphalt. 20% shows the best performance in their study. For Kara and her team, they replaced the granite aggregate with ceramic aggregate with proportion of 0% up to 40% weight of aggregates with increment of 10%. They conducted Marshall stability and flow tests, repeated dynamic loading rate tests, and fuzzy logic. From the result, they conclude that when when ceramic waste is present, wearing resistance improves up to 15.5% and freezing and thawing resistance improves up to 22.7%. They also conclude that 30% of ceramic waste aggregate by weight was lighter by 11% compared to the control sample. Actually, Kara and her team started the research in 2015 with just Marshall stability and flow tests. Then in 2017, they add the fuzzy logic and repeated dynamic loading rate. The conclusion made is the same in 2015 and 2017. From Kera's study, it shows that replacing the conventional granite aggregate with 30% of ceramic waste is the best, while in Muniandi's study, it shows that replacing granite aggregate with 20% of the ceramic aggregate is the best. So therefore, in my study, I will make the scope smaller with just replacing the granite aggregate with 15%, 20% and 25% of the granite aggregate with ceramic aggregates. I will conduct the Marshall stability and flow test and then compare it with JKR spec. This is the flow chart of the methodology for FYP. It begins with the introduction, material selection, sample preparation, Marshall mix design, Marshall stability and flow test, finally the data analysis. Mix design proportion. Partial replacement of ceramic aggregates used in design mix is 0%, 15%, 20% and 25% with 15 samples each. Since there is 4 mix design, there will be 60 samples. Mix design method used in this study is Marshall mix design. I will be using asphalt binder with penetration grade 60-70 since it is readily in the lab. I will do the aggregate gradation, followed the AC14. Finally, all the 60 samples will be tested with Marshall stability and flow test. The Marshall stability test was carried out by soaking and heating the AC40 mixture in a water bath to a temperature 60 degrees Celsius for 30 minutes and then test the AC40 mixture with Marshall equipment. The stability and flow will be determined. Data obtained will be analyzed and 6 graphs need to be plotted to determine the OBC. The 6th graph is density versus asphalt content, void fill asphalt VFA versus asphalt content, voids in total mix VTM versus asphalt content, stability versus asphalt content, flow versus asphalt content, and finally the stiffness versus asphalt content. All 6 graphs will be plotted to determine the OBC. Once OBC is determined, we will compare the stability and flow with JKR spec. This is the JKR spec. We will see whether all the 4 mix design is meet the requirement of JKR specification or not. For the conclusion, in a nutshell, this study will use ceramic aggregates as a partial replacement for the virgin aggregate in the HMA. This approach will reduce the amount of waste from ceramic tile industry from directly goes to the landfills. This alternative method uses the waste material in the HMA as aggregates can preserve the environment and reduce the consumption of natural resources and at the same time save a lot of money. Because like I mentioned in the literature review part just now, HMA with ceramics are lighter compared to conventional aggregates. When it is lighter, the transportation cost can be reduced and gas emission also can be reduced. This is the Gantt chart for future works. The progress for the FYP2 will follow the Gantt chart as shown. That's all from me. Thank you.